Good morning, everyone. This is Mrs. Bokerman. We are going to make short little quick videos for you to kind of teach you what you need to know while we're gone. This is purely a review from geometry, and we're going to talk about trig ratios, which is just the side lengths. So to do that, let's kind of review really quickly. You have to pay attention to what angle we're talking about. Okay, we're never going to use the right angle. We're always going to use the other two. So really pay attention to the labels. So if I'm looking at angle B, then I'm looking at this angle up here, right here. And in terms of B, I have to consider what is opposite to B, what is adjacent, and what is the hypotenuse. Now, the easy one to figure out is always the hypotenuse because it's always across from the 90-degree angle. So wherever the 90-degree angle across from that is the hypotenuse. Now, if I'm looking at angle B, across all the way across from angle B, that would be the opposite. So this would be opposite. And so adjacent would be the closest one to it. So this side would be the adjacent. Now that's very important because you would get all of these wrong if you didn't know the opposite, adjacent, and the hypotenuse correctly. Now everything would change, not everything, but most things would change if I then wanted to look at angle C. So if I wanted to look at angle C, what stays the same is the hypotenuse because it's always across from the right triangle. But if I'm now doing angle C, then opposite and adjacent would flip. Adjacent would be now right next to C, and opposite would be all the way across from C. Okay. So we have to remember sine, cosine, and tangent. And there was that little phrase called SOHCAHTOA to help you remember it. But the sine is the opposite over the hypotenuse. The cosine is the adjacent over hypotenuse. And the tangent is the opposite over adjacent. So you might want to pause the video and write that down somewhere if you don't remember it, or write down SOHCAHTOA because you need to understand what those mean. Okay, so let's get into a triangle. So we're going to give you a triangle, and notice we have A, B, and C labeled for you, and it can be in any order. Okay, now the first thing I want you to realize is you are missing a side. You're missing this side here. So you need to use the Pythagorean theorem from last year to figure out this side, which the Pythagorean theorem says a squared plus b squared equals c squared. C is always your hypotenuse. So it doesn't matter which is A and B, that doesn't matter, but C has to be your hypotenuse. So you'll notice I'm missing this leg, but I have this leg and I do have the hypotenuse. So I'm going to start with a squared equals 8 squared equals 17 squared. Okay, now to do some algebra, I'm going to subtract this 8 squared to the other side, and at the same time, I'm going to actually figure out what they are. So 17 squared is 289, and 8 squared is 64. So if I subtract those, I get 225. Now, I always need to double check, and to get a by itself, I take the square root, and I get actually 15. So that means that I can put a 15 right here. This side length is now 15. Okay, and I can now that I have all the sides, I can now find these things. So let's do all the A's first. So I'm going to focus on angle A. This is going to be my base. Okay, so if I want the sine of this angle, all I have to do is go across, because it's opposite, which is 15, over the hypotenuse. And the hypotenuse is always across from the right angle. So the correct answer for A is 15 over 17. Now, you do have to reduce it if possible. So you could double check on your calculator, 15 divided by 17, and then hit math fraction if you have a graphing calculator. But those do not reduce. Okay, so now the cosine is adjacent over hypotenuse. So adjacent to this would be looking at the 8 that's right next to it. Okay, and then the hypotenuse is 17. So it's 8 over 17. And lastly, tangent is the only one that doesn't use the hypotenuse, and I have to use the opposite, which is all the way across, 15 over 8. And that's angle A. Now, we're going to do the same thing, but now we're going to focus on angle C. So I'm going to no longer focus on angle A. So if I focus on angle C, across from it is 8, hypotenuse is 17. The cosine is next to it is 15. Why did I not use 17? Because that's next to it. Because 17 is the hypotenuse. So next to it is 15. Hypotenuse is 17. And then the tangent is opposite, all the way across is 8. Adjacent is 15. All right, let's try one more example because those were nice whole numbers. So here's a new triangle. Doesn't matter how it's labeled, but immediately I want you to know you're missing a side right here, BC. So I have one side and I do have the hypotenuse. Again, it's across from the right triangle. So the first thing I'm going to do is try to figure out what that missing side is. So I take the side squared plus 3 squared, and that's got to equal 7 squared. So similarly, I got to get a by itself. So I subtract this 3 squared to the other side. At the same time, I said that 7 squared was 49 and 3 squared was 9. Okay, so if I subtract those numbers, I get 40. Then if I take the square root, I get the square root of 40, and that is a decimal. So we're going to actually leave it as the square root of 40. Okay, so now I can type right here. Come on. Come on. Square. Oop, my computer is freezing. Okay, but I would label this side right here square root of 40. Okay, so now it's working. Square root 40, just so you can see what that looks like. Okay, so now we can do our trig ratios. So if I'm looking at angle A, I'm going to look at angle A, which is right here. Okay, so opposite angle A would be square root of 40, and the hypotenuse is across from the right triangle, which would be 7. So that's what I got, square root of 40 over 7. Cosine of A is adjacent. It's not the 7 because that's a hypotenuse, so adjacent is 3 over 7. And tangent is all the way across, square root of 40 over 3. Similarly, now I'm going to change it. Now I'm going to focus on B instead of A. So always know which angle you're talking about. Okay, so if I'm now looking at B, across from B, opposite B is 3, hypotenuse is still 7. Now the adjacent is now square root of 40, hypotenuse is 7. And tangent is opposite, which is 3, over the square root of 40. And there you have it. Those are trig ratios. Okay. The only thing I want to point out in the next video, and I have it kind of already done for you, is the fact that at times you will need to reduce. So you can pause it and kind of look at this one. But you'll notice in the tangent, I got a 12 over 10. I have to reduce that to 6 over 5. And similarly, then for C, I got 10 over 12, and I have to reduce that to 5 over 6. So you will get it wrong on Math Excel if you do not reduce. Okay, so pause the video, take a second, make sure you understand trig ratios, and let me know if you have any questions. Otherwise, your homework is Math Excel.